Continuing on with our discussion on temperature and heat, let's move on to modes of heat transfer, starting with heat conduction or thermal conduction. There are three mechanisms or modes by which heat is transferred. We have conduction, convection, and radiation. Heat or thermal conduction, heat or thermal convection, and heat or thermal radiation. Heat transfer rate is the rate at which heat flows through a body or the rate at which heat flows from one body to another. Heat transfer rate, you can think of it in terms of how fast is heat being transferred from one point in the object to another point in the object. Variable for heat transfer rate is capital H. H is rate of delivery of heat. So dQ over dt, differentiation of Q with respect to time. Getting the average, H average is just equal to total heat transfer divided by total time. H average is equal to Q over T. Unit is Q, joules, T, seconds. So unit for heat transfer rate is joules per second. Similar to power, so we can use the unit of power for heat transfer rate, watt or watts. Note that for the most part, when we say, at least as far as our course is concerned, when we say heat transfer rate, for the most part, we are talking about average heat transfer rate, average H. But don't forget that H, instantaneous heat transfer rate, H is equal to dQ over dt. Heat is transferred through solids via the mechanism of heat conduction or thermal conduction. Heat conduction is the dominant heat transfer rate or heat transfer mechanism rather in solids, so much so that when we say heat transfer through solids, we're talking about heat conduction. Say you have an object. One side has temperature TH, the other side has temperature TC. TH is considered the hot temperature or the higher temperature side, and TC is considered as the cold temperature or the lower temperature. TH is greater than TC. Heat will flow from hot to cold. That's the normal direction of heat flow. So from hot to cold, if we look at how fast heat is being transferred from TH to TC, we are looking at heat transfer rate, H average, and H average is given by Ka TH minus TC over L. K is thermal conductivity of the material, unit, watts per meter Kelvin. This is property of the material. Each material has its own value of thermal conductivity. A is cross-section area through which heat is flowing. L is length of the object, the distance between TH and TC. H average is equal to Ka TH minus TC over L. Heat conduction through solids. In some cases, conduction is described in terms of thermal resistance of the material. Thermal resistance is basically the inverse of thermal conductivity. R, specifically, R is equal to L over K, unit meter squared Kelvin per watt. R is equal to L over K. Thermal resistance of the object, be able to convert thermal resistance into conductivity if ever the problem gives you thermal resistance instead of thermal conductivity. Again, be able to convert R into K so that you'll be able to perform heat conduction analysis. H is equal to Ka TH minus Tc over L. Now, an object may be comprised of only one material, or it may be comprised of two or more materials layered together. When connecting or layering materials together, the materials are either layered in series or they are layered in parallel, or perhaps a combination of the two. For materials that are connected or layered in series, say you have an object comprised of two materials, material K1, material K2, TH is on this side, and on the other side you have TC. The two materials are layered one after the other. The materials are layered in series. For materials in series, TH, TC, hot temperature, cold temperature, heat will flow from hot to cold. First, it will flow through material 1 and then flow through material 2. The temperature at the border or interface between the two materials, the temperature Tx, will adjust in such a way that the heat transfer rate through K1, through material 1, is just equal to the heat transfer rate H2 through material 2. H1 is equal to H2. There's only one heat transfer rate value through the object for materials in series. So H average is equal to H1 is equal to H2. On the other hand, for materials in parallel connection or layering, say you have an object comprised of two materials, K1 and K2. K1, say K1 is placed on top of K2 side and TC on this side. Each material poses a parallel path or alternative path from TH to TC. The materials are layered in parallel. And for parallel materials, for materials in parallel layering or connection, the heat transfer rate will add up. Heat transfer rate H1 through material K1, heat transfer rate H2 through material K2, the 2H, the 2 heat transfer rate will add up such that H average, the total heat transfer rate through the object, H average is equal to H1 plus H2. Next, we have heat convection. Now, heat convection is a very large and complicated topic, well beyond the coverage of our course, coverage of basic physics. Heat convection is heat transfer rate with fluids for the most part. I will leave it up to you to look up heat convection in textbooks. Look up or open rather any college physics, basic college physics or basic physics textbook. When you open the textbook to the section of heat convection, you will see that the section is mostly discussion, little to no equations to memorize and use. So I leave it up to you to read about and familiarize yourself with the concept of heat convection. Suffice it to say that heat convection is heat transfer via the physical motion of fluids. Because the fluid is moving from one location to another, heat is being transferred from one location to another. And depending on how fast the fluid is moving from one location to another, that will determine how fast heat is being transferred. Conduction also happens with fluids, but it tends to be negligible compared to convection. Convection being the dominant mode of heat transfer in fluids. So much so that when we say heat transfer with fluids, we're talking about heat convection. There are two types of convection. We have natural convection, which involves the natural motion of fluids. Say you are feeling hot, you open the window, and as a result, cold air flows into the room. That's an example of natural convection. Another example of natural convection is hot air being lighter than cold air. Hot air naturally rises, while cold air naturally descends. On the other hand, we have forced convection, forced motion of fluids. Example, you are feeling hot and you turn on the electric fan. The electric fan forces air to move from one location to another. Any heat transfer due to the motion of that air, you have forced convection. And that's it for now. That's it for our discussion on heat conduction. In the next video, we'll continue our discussion on temperature and heat. We'll look at the last mechanism of heat transfer, heat radiation. So again, that's it for now. Thank you for watching.